So it's 85.11 multiplied by 39.34. So P1 saturation is 85.11 minus 0.40. 85.11 minus 39.31. So can you able to solve this one, and can you give me the answer of total pressure? Students, can you do it in your calculation? Can you able to give the answer? Okay. Devanshu says it's 50 kilopascal. Okay, it's 50 kilopascal. Done. So total pressure we calculated. Now what we have to calculate? We have to calculate the x1. X1 is very easy to calculate because x1 we know. X1 is equal to P minus P2 saturation divided by P1 saturation, P2 saturation. So if I calculate all values of 50.09 or 50 something 50 we take minus 39.31, 85.11 minus 39.31. So can you give me the answer of the mole fraction x1? Okay, the answer is 0.234. Okay, 0.234 or 0.235. Okay, very good. So last example we'll do, and then we stop this lecture. Okay, so let's calculate one more example, and then based on it we'll finish the lecture. So a somewhat long example, the systems of benzene and toluene. For ideal liquid solution, vapor pressure data are given below. Calculate. So one table is given. Let me draw this table. Then we say what is the calculation we have to do. So we have temperature. Temperature is in Kelvin. So different temperature is given. P1 saturation, kilopascal. P2 saturation is kilopascal are given. And now હું જે રીતે કરું એ કઈ કરા એનાથી થાય છે ગાંડા વેળા કરો એટલે વાંધો નહીં. So the different temperature is given 353, P1 101.3, P2 saturation 39.6. $383 and 383.6. Either 116.9, 135.4, 155.7, 179.1. थोड़ी कच्चे हाँ करना है ना 233, 240, 46, 54, 63.3, 74.2, 86, 99, 101.3. So these are the data are given. Using this data, what we have to make, we have to equilibrium data. First things we have to calculate the equilibrium data. For these systems, at 101.3 kilopascal, and also formulate the relative volatility. Here the important is to formulate relative volatility. So alpha value we can using P1 saturation divide by P2 saturation. So using this one we can formulate the relative volatility. So now we have to use the equation. Using the equation, just we have to using table we have to add more things, nothing. So like temperature T, solution, we have to use this equation. Using x, or we can choose x is equal to
bedroom to રસોડા hall.
So we have to calculate X and Y, and we can calculate the relative volatility alpha. Alpha we can calculate P1 saturation divided by P2 saturation. Then so let's we have a table T in kilopascal, P1 saturation, P2 saturation, X, Y. And so let me do this in a Excel, because in Excel it's effectively and it's fastly. So let me do this in Excel. So just 1 minute. As I open the Excel. Just 1 minute, I open Excel and then so this is the Excel. So Excel we have a temperature T. We have a temperature T is in Kelvin. We have a P1 saturation. We have a P2 saturation. We have to calculate X. We have to calculate Y. Also, we have to calculate relative volatility. Okay. So let's calculate this one. Different T are given. What are the values of T is given? So 353.1, 353.1, then 358, then 363, 368, 373, 378, 383, 383.6, 101.3, 116.9, 135.4, 155.7, 179.1, 204.2, 233, 240. P1, P2 saturation we have 39.6, 46, 54, then 63.3, 74.2, 86, 99, 101.3. Okay, so now how can we calculate X? X we can calculate is equal to bracket P, total P, how much? We have a 101.3 kilopascal, 101.3 minus P2 saturation. What is the P2 saturation here? It's a P2 saturation. Divide by P1 saturation minus P2 saturation. This one here, this one. So we can calculate the value of X. So here 1. So if I extend this, then I have a different value of X. Now, how to calculate Y? Y is equal to X multiplied by P1 saturation divided by total pressure 101.3 kilopascal. Then, so y is equal to 1. Here we also get a different value of y. Relative volatility is equal to P1 saturation divided by P2 saturation. So we get a 2.55. So these are the different volatilities for this. And average volatility, if I do the average of it, average volatility, then AV average. So here we take a average, and once we take average, and 2.44 is the average. So we can generate here we can generate the y and x data using this relative volatility. So this is the table. Let me copy and let me paste here. So this is the paste here. So once I beat, then I'm getting the relative volatility equation. Y is equal to, we can have a relative volatility is equal to y is equal to alpha x divided by 1 minus 1 plus alpha minus 1 multiplied by x. So alpha value will be 2.442. 2.44 x divided by 1 plus 1.45 x 1.44 x. So different value of x, we get different value of y, and we get the equilibrium value. Then so this is the third example. Yes, total pressure Devanshu is given here is a 101.3 kilopascal here. Yes, 101.3 kilopascal is given. Okay, so karna hai. So 101.3 kilopascal is a total pressure Devanshu given here. Okay, so these are the three examples. Now from next lecture we'll start with the new topic, and then we go subsequent topics for the this phase equilibrium, the vapor liquid equilibrium. So now stop here. Anything from your side, then you can say. Otherwise, you can left the meeting, and we'll meet on tomorrow or day after tomorrow. Take care of yourself, because Corona in peak. Okay. If you are going for your job, then you can also take care. We are not going to college because we have a work from home. Deepak, you also take care during the in hostel, and Devans, you take care during your job. Kosa, you also take care in your office. So I end meeting here for all of you. We'll meet next lecture.